All right, this video is going to kick off our unit on derivatives. And the way I wanted to start doing this video was to kind of explore the slope problem that I talked about in the big picture video at the beginning of the school year, except now we can start to introduce some limit vocabulary into it since we've learned about limits between then and now. So let's go back and take a look at our GeoGebra screen. All right, so here is the function y is equal to x squared. And I have here highlighted the point A, which has coordinates 2, 4. All right, so if I picked a different point B on the curve, and I drew the line that connected A and B, it would be easy for you to identify the slope of that line. All right, so this is going up 1 and over 1. So the slope of this line is 1 over 1. If I moved the point B over here, now the slope is 3 over 1. So finding the slope is something that we have a lot of experience doing when we've got two different points on the plane. All right, and so that is something we've been calling the slope. Another phrase we've been trying to encourage you to remember, I don't know if we've been successful or not, is average rate of change. Okay, so for instance, at this point, let's say that this graph represented my bank balance, and this is the number of days since January 1st. All right, so this is January 1st, January 2nd, January 3rd. This is December 31st. So what I could say is the average rate of change in my bank account between December 31st and January 3rd is $1 per day. $1 per day, $1 per day, $1 per day. The average rate of change of my bank account between January 2nd and January 3rd is $3 per day. Okay, and so you can see that my bank account balance was not a straight line during this time. But when I talk about average rate of change, I kind of pretend that it does. All right, that was the average of what it was doing. The first day, I actually lost $1, but I'm pretending that I gained $1 because it all worked out in the end. So I can move this value of B around, and you can see how the line changes and the slope of the line is changing until B is sitting right on top of A. And when B is sitting right on top of A, the line disappears. Why do you think that is? Well, because when A and B are the same point, there's no unique line that connects A and B because they're the same point. Lots and lots of lines go through that point, and we don't know which one is the one that we're interested in. We only know what that line is when there are two different points. All right, but that is an interesting thing, knowing exactly how quickly my bank account is changing exactly on January 3rd. All right, and so this is an idea. Rather than calling it average rate of change, we're going to call it the instantaneous rate of change. I want to know what's the instantaneous change in my bank account balance on January 3rd. And the answer to that question is, what it's going to be is it's going to be the limit of the slope as point B gets closer and closer to point A. All right, so you see that the line is kind of homing in on a specific slope when I'm coming in from this side. I can also see that it's approaching a slope as it comes in from this side. And so what we want to do is we want to calculate the limit of the average rate of change as B approaches A. Okay, so this gives you a little bit of an idea of what average rate of change and instantaneous rate of change is. Average rate of change is something you've been dealing with for years, and instantaneous rate of change is this new idea that we're going to be able to tackle in the next video with the help of what we know about limits.